integration is nothing but log of modulus of secant theta. Secant pi by 4. You know that secant pi by 4 is a reciprocal of cos. Cos pi by 4 means cos 45 degree. Cos 45 degree is 1 by root 2. So secant 45 degree is root 2. X squared is equal to 2. If you substitute, it is differentiation 2x only. If you substitute also x squared plus 1, differentiation of that also 2x only. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learned many problems on a substitution method. In today's session, dear students, here we are having session number 20 and chapter number 7 called integrals. And what are all the topics we are going to study under this? Again, evaluation of the definite integrals by substitution method. Now, what are all the rules for the substitution method? Let us move on to. So this will take to evaluate integral a to b f of x dx by substitution method. The steps could be as follows. Consider the integral without the limits and substitute y is equal to f of x. That means whatever you are going to substitute, that should give the differentiation inside the integrals. Or x is equals to g of y. Either you can terms of x or in terms of y you can substitute. Okay. So to reduce the given integral to an known form. Okay. And then you are going to have integrate the new integrand with respect to the new variable without mentioning the constant of the integration. So without mentioning the constant of that integration, you are going to take it as what? Evaluating the new variable. And then you are going to have resubstitute for the new variable and write the answer in terms of the original variable. Okay. After doing that, you should resubstitute the new variable and write the answer in terms of that original variable. So find the values of the answer obtained in 3 at the given limits of an integral and find the difference of the values at the upper and the lower limit. This is as usual step what we have studied in the last classes. Now we'll be moving on to the problem what they have given. Integral 0 to 1 x divided by x squared plus 1. Now dear students, here in the denominator you are having x squared plus 1. You know already differentiation of x squared is nothing but 2x, but numerator do not have 2x. So let us multiply and divide it by 2. What happens to the condition? Which implies divided by 2 and multiply by 2 divided by x squared plus 1 into dx, isn't it? Now, you are going to substitute denominator. Anyway, x squared is equal to 2. If you substitute, it is differentiation 2x only. If you substitute also x squared plus 1, differentiation of that also 2x only, isn't it? So, I am going to substitute let x squared plus 1 is equal to t. So, differentiate this with respect to x. You are getting 2x into dx is equal to dt. Right. Now you can have, which implies 1 by 2 into 2x into dx is nothing but dt divided by x squared plus 1 is nothing but t. Now you know this. After doing the substitution, please dear students, you have to change the limit of the function. Now here, when x is equals to 0, isn't it? What will be t? Let me substitute from here. So when x is equals to 0, t will be is equal to 0 squared plus 1 which is 1, and then when x is equals to upper limit 1, t will be is equal to 1 squared plus 1 which is nothing but 2. I hope you got this one. So when x is equal to 0, t is equal to 1. When x is equals to 1, t is equal to 2. Now you can integrate this aram say, that is 1 by t integral is nothing but log mod t. So 1 by 2 into log of modulus of t from the limit 1 to 2. Now, and then you can substitute 1 by 2 into, now log of modulus of t, you can have log modulus of 2 minus log modulus of 1, isn't it? Now you can have, this will be is equal to 1 by 2 into log modulus of 2 is nothing but 2. You know log 1 is nothing but 0, and this is your answer, you are going to get it. I hope you understood this problem. We'll be moving on to the next problem, dears. Integral 0 to pi by 2 sine 5 cos to the power of 5 into d5, isn't it? Now here differentiation of the cos gives you sine, or differentiation of the sine gives you cos. So here let me substitute for cos only because you are having cos to the power of 5. So therefore I am going to substitute let cos phi is equal to t. You know this cos by differentiating with respect to phi, you are getting minus sine phi into d phi is equal to dt, isn't it? So now you are going to do the substitution of the limit. They have given 0 to pi by 2. Let me substitute. When 5 is equal to 0, t is equal to, see, cos 0. Cos 0 value is 1. Similarly, when 5 is equal to upper limit is pi by 2. So cos pi by 2, cos 90 degree is always 0, isn't it? So t is equal to 0. Okay, now you are moving on to the substitution, which implies integral. See, cos 5 d5 is here, sine 5 d5 is nothing but what? Minus dt, because this minus sign will shift to that side. Minus I am writing here minus dt. Now cos to the power of 5 is nothing but t to the power of 5, isn't it? So t to the power of 5, now changing the limit, when 5 is equal to 0, t is equal to 1. When 5 is equal to pi by 2, t is equal to 0 you are having, right? Now if you change this limit 1 to 0 as 0 to 1, it will be changing as negative integral. So therefore you can have negative of negative 0 to 1 t to the power of 5 into dt. Now minus into minus, which will become plus, which is 1 only. So integral of 0 to 1 t to the power of 5 into dt, which you can have t to the power of 6 divided by 6 from the limit 0 to 1, which happens 1 to the power of 6 divided by 6 minus 0 to the power of 6 divided by 6, which will be 1 by 6. And this is your final answer. You are going to get it as DS students. I hope you understood this one. DS will be moving on to the next problem. What they have given? Integral 0 to 1 sine inverse of 2x divided by 1 minus x squared. DS, you know already sine 2 theta in terms of tan. What you can write? 2 tan theta divided by 1 minus tan squared theta, isn't it? If you look this, it is accordingly 2 tan theta divided by 1 minus tan squared theta. Therefore, you can do the substitution x is equal to tan theta. So, put x is equal to tan theta. Then differentiate with respect to theta. So, you can get differentiation of x is nothing but dx is equal to tan theta is secant squared theta into d theta, isn't it? Now you can have, which will be implying that changing the limit. Now if you want to change the limit, 0 to 1 is there, put x equal to 0. When x is equal to 0, now tan 0 value is nothing but you can have here, see, which implies theta is equal to tan inverse of x, right? Now tan inverse of 0 is nothing but tan 0. Tan inverse of 0 is nothing but you are having 0. So therefore theta will be is equal to 0. Similarly, when x is equal to upper limit is 1, tan inverse of 1, in which degree you are having tan inverse of 1? 45 degree. So 45 degree can be written as in radian pi by 4. That's it. Okay, now you can change the limit here, which implies integral when x is equal to 0, theta is also 0. When x is equals to 1, theta is pi by 4. Now sine inverse of, you can change this one to tan theta divided by 1 minus tan square theta into dx is nothing but secant squared theta into d theta. Now this will become what? Sine 2 theta, as I have written the formula, 0 to pi by 4 sine inverse of sine 2 theta into secant squared theta into d theta. Now sine inverse of sine 2 theta is nothing but 2 theta into secant squared theta d theta, isn't it? You can have, now you are going to choose according to what? Integral by parts. Now you can choose integral by parts according to the iLearn rule. Algebraic is the first function and trigonometric is the second function. So therefore this is the first function you can choose and this is the second function you can have. So accordingly, if I do it, don't forget to write the limit, which is 0 to pi by 4, which implies first function into integral of second function minus integral of d by d theta of first function into integral of second function into d theta, right? Now you can just simplify this. 2 theta is into, which implies that 2 theta, integral of secant squared theta is nothing but tan theta. So therefore tan theta, you can apply the limit at last. So minus d by d theta of 2 theta is nothing but 2 will come outside, d by d theta of theta is 1. So 2 into 1 is 2 only. Again, integral of secant squared theta is tan theta into d theta, right? Now you can have 0 to pi by 4 as a limit, which implies 2 theta into tan theta minus this 2 will come outside. Tan theta integration is nothing but log of modulus of secant theta. So therefore, log of modulus of secant theta from the limit 0 to pi by 4. Now you can apply the whole term upper limit. Wherever theta is there, you are going to replace pi by 4 minus. Wherever theta is there, replace 0 because upper limit minus lower limit. So you are having 2 pi by 4 into tan pi by 4 minus 2 log of modulus of secant pi by 4. This is the upper limit minus, open the bracket, 2 into 0, correct, into tan 0 minus 2 log secant 0, right? Now you can close the bracket, which will be implies that, see, 2 into pi by 4, 2 ones are 2 twos are. So pi by 2 into tan pi by 4 value is 1 minus 2 into secant pi by 4. You know that secant pi by 4 is a reciprocal of cos. Cos pi by 4 means cos 45 degree. Cos 45 degree is 1 by root 2. So secant 45 degree is root 2. So therefore you can have 2 into log root 2, right? Now minus, see, 2 into 0 is 0, into tan 0 is 0, 0 into 0 is 0, minus 2 log secant 0. Secant 0 value, cos 0 value is 1, secant 0 is also 1. So minus into minus is plus 2 log, see, you can have 1, isn't it? So this term also will become 0. Why? Because log 1 value is 0. So therefore the lower limit is completely eliminated. Now pi by 2 into 1 minus, you can write this one as 2 into log 2 to the power of 1 by 2, which implies that pi by 2 into, this look like log m power n. Log m power n is n log m, which is nothing but minus 2 into n log m. Now 2 will get cancelled. The remaining answer or the final step is pi by 2 minus log 2. And this is your answer for this question, dear students. I hope you understood this one, how to apply the limit by substitution method. Now we'll be moving on to the next problem. Integral 0 to 2 x into under the root of x plus 2. Let us integrate this one. Integral 0 to 2 x into under the root of x plus 2. Here you have to write it. Integral 0 to 2 x into under the root of x plus 2 into dx. Okay. Now you can substitute under the root of x plus 2. That is what getting complicated here. Under the root of x plus 2 is equals to t. If you substitute under the root of x plus 2 is equals to t, you can have squaring on both the sides, isn't it? You can get x plus 2 is equal to t square. Now you can differentiate this with respect to x. You are going to get it as dx is equal to 2t into dt, right? So therefore dx you can substitute as 2t into dt. Now you can substitute x plus 2 is equal to t squared, means you can have x is equal to t squared minus 2. Now changing the limit, when x is equal to what? Up lower limit. When x is equal to 0, what will be t? So t you can have, which is nothing but under the root of x plus 2 here. So 0 plus 2 is nothing but root 2, right? When x is equal to, if you are having 2, now you can have 2 plus 2 is nothing but 4. So root 4 is nothing but t is equal to 2 only. Now you can do the substitution, which implies that integral in place of x equal to 0, t is equal to root 2. In place of t is equal to 2 only. Now x is nothing but what we have substituted. X is here t squared minus 2, isn't it? So under the root x plus 2 is nothing but t. Now you are going to get under the root of x plus 2 is nothing but you are getting it as t. So therefore you can have, now dx is nothing but 2t into dt. I hope you understood this one. Now you can have, so 2t into dt, 2t will be t squared, it will become, it is multiplied inside. So root 2, 2t squared into t squared is 2t to the power of 4. So again, minus 2 into 2 is 4. T into t is t squared, right? So t squared into dt. Now you can simplify this one. 2 into t to the power of 4. From the limit root 2 to 2, 2 into t to the power of 4 into dt minus 4 into t squared into dt. From the limit root 2 to root 2. If you know directly, you can integrate. Now you can integrate, this will become 2 into t to the power of 4 is t to the power of 5 divided by 5 minus 4 into t squared is nothing but t cube divided by 3 from the limit root 2 to 2. I hope you understood this one. Now you can have applying the limit. First upper limit, let us apply. What is that? Which implies 2 into 2 to the power of 5 divided by 5 minus 4 into 2 cube divided by 3 minus, open the bracket, lower limit is root 2. So 2 into root 2 to the power of 5 divided by 5 minus 4 into root 2 to the power of 3 divided by 3. Now you can simplify this one, which implies that now 2 into 2 to the power of 5, which is 2 to the power of 6, which will be giving you, now here you can take 2 as a common factor everywhere. 2 into, now 2 to the power of 5 is nothing but 32. So 1 by 5 into 32 minus 2, if you take common, 2 will be remaining. 2 2s are 4. So 2 cube is nothing but you can have 8 divided by 3, right? So minus, here also 2 can be taken common. So which happens, you can close the bracket here of the flower. You can write root 2 to the power of 5 as root 2 into root 2 into root 2 into root 2 into root 2, right? Which happens here, root 2 into root 2 is 2. Again root 2 into root 2 is 2. Remaining is 1 root 2. So you can write this one as 4 root 2. Similarly, root 2 cube can be written as root 2 into root 2 into root 2. Which happens, root 2 into root 2 is 2 root 2. I hope you got that one. Therefore, replacing that, 2 already taken common factor here. So, root 2 to the power of 5 is nothing but 4 root 2 divided by 5 minus. So, 2 already taken common factor. So, 2 by 3 into root 2 cube is nothing but 2 root 2. Now, multiplying the minus sign you can have, which implies, so close the flower bracket here. 2 is already outside. 2 into, so you can open up the minus sign now. So 32 divided by 5 minus 8 2s are 16 divided by 3 minus 4 root 2 divided by 5 minus into minus is plus 2 2s are 4 root 2 divided by 3. Now you can close the bracket. Now if you take it as, see 5 3s are 15 as the LCM, you can write 2 into 15 will be the LCM. So you can have, so 5 3s are 15, which you can get it as 32 into 2 is 2 3s are 6, 3 3s are 9, right? Minus, here 3 5s are, so 16 5s are 80 you can have, minus here 4, 5 3s are, so 3 4s are 12 root 2, again 3 5s are, that is 5 4s are 20, right? So plus 20 root 2. Now which implies that 2 into, see you can have 96 minus 80 is nothing but, 96 minus 80 is nothing but 16. 16 minus 12 root 2 plus 20 root 2. 20 root 2 minus 12 root 2 is nothing but 8 root 2, right? Divided by 15. Now which implies that you can have here the common factor is 8. So therefore 2 into 8 into 8 2s are 16 plus root 2 divided by 15. 2 can be written as root 2 into root 2. So therefore the final answer you are going to get it as 2 into 8 is nothing but 16. Now 2 can be written as root 2 into root 2. Root 2 can be taken outside. 16 root 2 into another root 2 is remaining here plus 1 divided by 15. So this is your answer you can have, dear students. I hope you understood this one. Now we'll be moving on to the next problem. Integral 0 to pi by 2 sine x divided by 1 plus cos squared x into dx. Now substituting the denominator here, cos x is equal to t, you are going to get sine x dx, isn't it? So therefore let me substitute here. Let cos x is equal to t. So differentiating this with respect to x, you can have minus sine x into dx is equal to dt. So changing the limit of the function there, if you put x is equal to 0, t is equal to cos 0. So t is equal to cos 0 value is 1. If you take x is equal to pi by 2, t will be is equal to cos pi by 2, which is nothing but 0. Right? Cos 90 degree. Now you can substitute here integral when x is equal to 0, t is equal to 1. When x is equal to pi by 2, t is equal to 0. Minus sign is there. Sin x into dx is nothing but minus dt divided by 1 plus cos is nothing but t squared, because already whole squared you are having. So therefore if you change the limit, minus into minus, it will become minus of minus 1. 1 to 0 as 0 to 1, so that only this minus will introduce dt divided by 1 plus t squared. Now you can have, which implies that minus into minus is plus, so 0 to 1 integral of dt 0 to 1 dt divided by 1 plus t squared. So this is look like what? It will look like tan inverse t, right? So tan inverse t from the limit 0 to 1, apply the upper limit first. Tan inverse of 1 minus tan inverse of 0. You know tan inverse of 1 is nothing but 45 degree, which is pi by 4, minus 0. Tan inverse of 0 is 0. So the answer you are going to get it as pi by 4. And this is your final answer for this question. I hope you got this one. We'll be moving on to the next problem. What they've asked. 1 to minus 1 dx divided by x squared plus 2x plus 5. Let us reduce x squared plus 2x plus 5. As by completing square method, what you are going to do? You are going to take it as x plus, that is coefficient of x squared must be 1, coefficient of x must be there here 2. So half of that one, half of that is 1. 1 whole squared, adding and subtracting. So x squared plus 2x plus 1 squared plus 5 minus 1 squared. This will become x plus 1 whole square plus 5 minus 1 is nothing but 4. So you can write x plus 1 whole squared plus this is nothing but 2 squared. Now you can have integral plus 1 to minus 1 dx divided by, you can write this one as x plus 1 whole squared plus 2 squared. Now this is in the form of dx divided by x squared plus a squared or a squared plus x squared, which is 1 by a into tan inverse of x by a. Right? So a replaces 2 there, which implies 1 by 2 into tan inverse of x replaces x plus 1 divided by 2. So from the limit 1 to minus 1. Now applying the upper limit as minus 1 and lower limit as 1, you can have, which implies 1 by 2 into tan inverse of, see, minus 1 plus 1. Minus 1 plus 1 divided by 2 minus 1 by 2 into tan inverse of 1 plus 1 divided by 2. Now you can have this one 1 by 2 into tan inverse of 0 by anything is 0 minus 1 by 2 into tan inverse of 2 by 2 is nothing but 1, which implies that 1 by 2 into 0 minus 1 by 2 into pi by 4. So therefore the answer you are going to get it as minus pi by 8. And this is your answer for this question, DS. Now we'll be moving on to the next problem. What they have given the question. Integral 1 to 2 1 by x minus 1 divided by 2x squared into e power 2x. Now you can have here, let 2x is equal to t. Now if you differentiate this with respect to x, 2 into dx is equal to dt. You can now have the substitution when x is equal to what it is. 1, t will be is equal to 2 into 1, which is 2. When x is equal to 2, 2 into 2 is nothing but t is equal to 4. Now you can change the limit there. When x is equal to 1, t is equal to 2, you can have. When x is equal to 2, t is equal to 4. So you can have here 2x is nothing but t. What is x then? So x will be is equal to, see here from here, x will be is equal to t by 2. Now you can substitute x is equal to 1 divided by t by 2 minus 1 divided by 2x I have substituted as t. So 2 as it is I can keep. So x you can substitute as t by 2 whole squared. Okay. So now e power t, because 2x I have substituted, dx is nothing but, you can substitute it as, see, if you replace here, dx is equal to 1 by 2 into dt, right? So 1 by 2 into dt. Now you can have here 2 to 4. This 2 will go to the numerator, 2 by t minus, you can have here 2 ones are 1, 2 will get cancelled. So another 2 will be remaining here, which will go to the numerator, 2 divided by t squared. Now you can have 1 by 2 into dt into e power t, right? Now 1 by 2, here also 2 can be taken common. If you take 2 common, 2 to 4, if you take here 2 common, 1 by t minus 1 by t squared. Here you can have e power t into 1 by 2 into dt. Now 2 will get cancelled. The remaining you can have, which implies integral 2 to 4, 1 by t minus 1 by t squared into e power t into dt. Now you can have, this will look like differentiation of 1 by t is nothing but minus 1 by t squared, isn't it? So therefore, this will look like is of the form integral e power x into f of x minus f dash of x, which is nothing but, you can write directly e power x into f of x. So therefore, f of x is nothing but 1 by t here. Here t will replace, that's it. So which implies that, which is in the form of that, you can write directly e power t into 1 by t from the limit 2 to 4. So apply the limit now. Apply the upper limit, e power 4 into 1 by 4 minus e power 2 into 1 by 2. If you want, you can take the LCM. So e power 4, LCM if you take it as 4 minus 2 e squared. If you want, you can take e squared common, e squared into e squared minus 2 divided by 4. And this is your final answer you are going to get for this question, DS. Hope you understood this session, how to do by substitution method, dear students. So in the next session, we'll be moving on to the next exercise of the definite integral. Okay, dears, I hope you understood this one. Thank you, dear students. Keep watching. Have a nice day.